Hi, in this video we're looking at the cosine rule. In triangle ABC, the capital letters represent your angles, the small letters represent your sides. The cosine rule states a squared is equal to b squared plus c squared minus 2bc cos of angle A. Quite complicated. So let's look for a pattern to help us remember this formula. The first part, a squared equal to b squared plus c squared, looks like Pythagoras. The second part, minus 2, we multiply the sides on the right hand side, and cos of the angle opposite the side we want to find. We can also use this formula to find angle A. So to find angle A, we'll have to move this on the other side, negative becoming a positive, move our a squared to the right hand side, and that's what takes place, and then we'll divide both sides by 2bc. So this formula can be manipulated to find the angles. If you look at the angle formula, you'll notice you need the entire three sides. So you need side, side, side to be able to use this formula. So when the sine rule fails, we have a cosine rule that can be tried out. And the cosine rule involves all three sides. Looking at our first example, we want to find small c, which is represented by side AB. So using the cosine rule, c squared, remember Pythagoras, this is not a right angle triangle, but I'm just using that to help me remember the formula. C squared is equal to a squared plus b squared minus 2ab cos of angle opposite the side we're finding. We're going to substitute. We have A, B, and angle C. So we're going to substitute A with 4.7, B with 5.8, and angle C with 28. And that gives us C squared using a calculator, 7.59. Please note that C squared. To find C, we find the square root, and that gives us 2.8. Next example, the question is to find small d. Good practice is always to label the sides with small letters. Opposite angle D is small d. Opposite angle E is small e. Now remember, this is two given sides and an included angle. So note, whenever you have two sides and a given angle, cosine rule works well. Sine rule will not work. So we have the formula d squared equal to e squared plus f squared minus 2ef cos d. E is 78.1, f 56.8, and angle D 48.9. We're going to substitute that, and working that out with a calculator, we get 3493.51, which is d squared. Square root that, you'll get 59.1 to be your d. Next question, we want to find an angle called Z. Notice we have no angles. So looking at the formula, Z squared is equal to x squared plus y squared. This should be y squared minus 2xy cos Z. We're going to manipulate the formula. We take this part on the other side becomes positive, and then we'll divide by 2xy. Also, the z squares move on the other side becomes a negative z squared. So, writing down that formula, remember we want to find angle z. There's our formula. Cos of z is equal to x squared, which is 15.8, plus y squared. Opposite y is 18.5. Z squared, opposite z is 13.1. We're going to substitute the values in, and that's what we get. Using your calculators, we'll get 0.71. Use our calculator to find angle Z. So we will type in shift cos 0.719. Close the bracket. And that gives us 44.0 for one decimal place. If we were going to 44.03. And that gives us our Z to be 44.0 degrees. Looking at next question says calculate the size of angle K. So let's try the sine rule first. Sine k over small k is equal to sine p. Well, we don't have side km, so we cannot use the sine rule. Now you notice we have two sides and included angle, which means the sine rule cannot be used. We have to use the cosine rule. But we can't find k directly. So what we need to do is find side km using the cosine rule. And that will give us p squared, which is side km, opposite p is small p, is equal to k squared plus m squared minus 2km cos p. So we're going to substitute that because your k is 43.8, your m, opposite m, is 56.3, and we have angle p given to be 53.2. So substituting the values in, using our calculator, we're going to get 2133.82. To find p, we're going to square root that. That gives us 46.2. So remember, p is actually km. Now that we have p, we can use the sine rule, which states that sine k over k is equal to sine p over p, which we found to be 46.2. Substituting the values in, we have sine k is equal to 43.8 times sine of 53.2 all over 46.2, and that gives me 0.759. Using my calculator, shift sine of that, we're going to get angle K to be 49.4. So remember, for this question, we first had to use the cosine rule to find Km, which is P. And then we used the sine rule, and we cross multiplied. And we divided by 46.2. And using the shift sign, we found angle K to be 49.4. Thank you.